Actually, there is an important point here. This is very much about age and things. And there is, let me think, I think one of the first Joe I did was on, it was 2002, and one of the points that I was making was, wouldn't it be nice if Java were an object-oriented language? I managed to get out of the building alive, but I made my case fairly clear. But now I'm coming back to this with an even more extended perspective. And unlike many of my other talks, this does not have a snappy title. What you're actually going to see is that once we've reached the end, I could have just called it programming languages. But putting the extra words in there is kind of helpful. So if you want to find me, I'm kind of all over the place. Ever since Elon Musk did us the service of fragmenting the social media space and allowing innovation in that space. Well done, Elon. You can find me in most places. And in some sense, I'm touching on a very semi-religious topic for many people. When it comes to programming languages, people have very strong opinions on those. And I want to say one of the most important things that I am talking about here is I wrote many, many years ago when I had hair like that. I've been a columnist for various magazines and things. And one of the things is I wrote a piece very much on the future of programming languages. And that was from the perspective of the late 90s. I wasn't completely wrong. But what was most fascinating is I was talking about trends as we understood them. And I made a number of observations. And I had some messages from people saying, "You're wrong, this is a much better language." See how people feel passionate about it? The problem is that person was wrong. They contained errors in the way they responded. Because I wasn't offering them a quality judgment, I was offering them a quantity judgment. That is a very different thing. And that's what I'm going to be looking at today. I'm also going to inject a little bit of humor, such as it is. There's more like this. Thank you. The best way to give a good talk is to start really low, and it gets better, yeah? So, let's talk about the past, the present, and the future. And I want to talk about why it is that programming languages are important. Because sometimes people say, well, do they really matter? I mean, you know, aren't they just a detail? We're not going to need programming languages. If you happen to believe that, then you're either the CEO of NVIDIA, or you have just sold your plot of NFTs secured through cryptocurrency in the metaverse, and are about to do AI consultancy. But the one thing we can say about both of those categories is you know absolutely nothing about software development and what really goes on. Programming languages are not details, because all I have to do is say, well, if it's just a detail, why don't you change the one you're using tomorrow? You know, just change the code. It doesn't matter. Monday, go in, tell the CEO, let's just ditch the code base that's in that language. You'll suddenly find that the thing you thought was a detail is fundamental. Now, there is a picture of the vehicle assembly building on the screen for a couple of reasons. I visited there. This is my photo. It simplifies copyright. This is my photo. We went on family holiday in July and went to Kennedy Space Center. It's kind of like a pilgrimage, at least for me and my younger one. And this is one of the most impressive buildings. It's 160 meters high. It is the largest freestanding building outside the urban spaces of America. It dwarfs the Saturn V's that it was built to contain. They're 111 meters tall. It is the largest single-story building in the world. It has one floor. All of these are impressive. It was completed in 1966. Its first customer, so to speak, was sadly the ill-fated Apollo 1 ground test, which rolled out in 1967. It's housed the shuttle, and it's also got glimpses of the future. It has this past, but you can see the Artemis mission is highlighted there. The reason this is there is because it is an impressive building. And I want you to look at that and say, well, what are the defining characteristics of this thing? What makes it what it is? And you probably wave your hands and say, the gross architecture, its history, and all the rest of it. And I'm here to tell you that the reason it is like it is for the stuff that you overlook and can't see. Materials and gravity. If you change the materials, you have to change the architecture. It's not going to be the same building. If you change gravity, it's not going to be the same building. All design is a response to a situation. This building looks like this because of gravity, but you can't see gravity. It is everywhere. And we take it for granted, like programming languages. They are not just a detail. They are the everything out of which we build details. They do matter. Of course, there's a lot of things we can change. So, going from 1967 to 1977, this is John Backus. We're going to see that lots of things end in 7. This is John Backus. John Backus and his team, in the mid-50s, created Fortran. This was a terrible language. It is also hugely important. So I often say, I have been paid to write Fortran. I recognize its place in history, and I just want it to stay there. It is hugely significant because one of the things is at the time, the prevailing belief was that you could not create a programming language that would produce machine code that rivaled the quality and efficiency of machine code handcrafted by a human. It's kind of like, okay, I'll take that bet. And you know what they didn't care about? Syntax, semantics, all the rest of it. They were just proving a principle. It was a proof of concept. How many of you have ever done a temporary fix or a proof of concept and suddenly that's your product? Yeah, it's not new. Now, the point is that John Backus, this is 20 years after. 20 years later, John Backus, and by the way, some of you are thinking, oh, I also know the name Backus. BNF, Backus Naur. Yes, it's that Backus. This is 1977. He receives the Turing Award. Fascinating thing about this paper, there's a number of fascinating things. Can programming be liberated from the von Neumann style, a functional style in its algebra of programs? First of all, the sheer length of the title. To the best of my knowledge, this is the longest title of any Turing Award speech. Okay, the first Turing Award was 1965 to Alan Perlis, but this is definitely the longest title. It's got punctuation. It's got its own microclimate. It's so long. It evokes a question. It actually, and this is an unusual paper because it's a paper of his speech, but it actually does give exactly what he describes. He actually describes an algebra for functional programming, a functional programming system called FP. There's a lot of really important stuff in this. One thing that is also noticeable is what he doesn't say. He does not use the word paradigm. I checked the paper. Paradigm does not occur once. In fact, people were not using the word paradigm to refer to programming languages or how we program. That would have to wait for the next year. Robert Floyd, 1978. This is the man we blame for introducing the word paradigm in its Kuhnian structure of scientific revolution sense. After this, people started using the P word. So anyway, what's John Backus say? I want you to note, this is 1977. Programming languages appear to be in trouble. I want you to spot the changes as we go through and see how much they're not in trouble now. I'm not saying there hasn't been progress. So here's 10 languages. Anybody program in any of these? Yeah, I thought so. All right. This is actually the TIOBE top 10 from last month. This is one of the most popular rankings, although people often question its methodology. Don't worry, we're going to look at other ones. This is from last month. September headline, Programming Language C at lowest position ever. Now, there are a number of reasons that this has come about. And it also shows what it takes to shift a language. It has actually taken the US government to start saying things about memory safety. That's what it takes to really move the needle. And guess what? it's still in the top 5. This is 5 Septembers ago. Okay, it was number 1. Now, here we are in 2021, 2022, 2023, and then we're back to now. Now, what I want you to notice is, yeah, there is movement. I'm going to make a point in this talk. Do not confuse stability with something being static. Okay? The programming language space is moving, but it is surprisingly stable. In fact, it does feel like somebody decided that for the last few years, at least, this is how we would work it out. We would just iterate through the various permutations and shuffle the top 5. Let's get a feel for this. This is 1 through 10. If you're looking at this going like, oh, well, yeah, it's not so bad. You know, there's always surprises. I will show you some other rankings. Wherever you're coming from, there are always surprises. You go, oh, I'm surprised that language is in there, but other languages not. That is true of every single ranking. But what is interesting here is it depends what your intuition is. What is your intuition about the degree of use or prevalence in terms of demand or presence online? Well, when you put the percentages there, and this is one of the things I kind of quibble with, there are 2 decimal places here. You can't quote this kind of stuff to 2 decimal places, but let's just go with them. The only way you can actually show some of the smaller ones is by quoting to 2 decimal places. The point here is, it depends what you know about rankings and things like power laws. This typically falls into a power law. Most social structures fall into power laws. This is completely unsurprising. It basically means that we are dealing with something that has a long tail and a dominant minority. To get a feel for that, the top 10 languages constitute more than 2/3 of those surveyed, which is about 100. Most languages are just point-something%. The top 5 is 55%. If you stay in this space, you've got a job. There's no worries about that. Also, I want to make another distinction. I'm not going to talk about these I'm not going to talk about languages in terms of success. I will talk about them in terms of dominance, although sometimes we slip up because we do equate the 2 words culturally. A language, if you have created a language and you have 5 users, and those 5 users are delighted and it has solved their problems, that is successful. It is not dominant, but it is successful. If you want to be the language that 50% of all developers use, and you don't achieve that, you have been unsuccessful, but you might still become dominant in that sense. Okay, so I want to make that distinction. Okay, let's look at these languages from another point of view. Okay, here's the ones that are highlighted. What do they all have in common? They were all created before the year 2000. Just look a little perspective on that. We are 25 years on from that. And the top 10 in TIOBE is absolutely dominated by languages from the last century. Here they are. The new ones, the kids on the block. I remember when Go was launched. My younger one was a toddler. My younger one is now at university. That's young. Let's look at the top 20. Yeah, there's a little bit more, but remember it's a tail. It's got a long tail. Those are really small percentages out there. Now, one conclusion you might draw is that programming language names have got shorter, which is perhaps why we put lang on the end of everything, because you can't, disambiguate. I'm going to Google for Go. Oh, damn, Golang, Elmlang, Rustlang. Yeah? But be careful with stats. We'll come back to that one. What we see is, over the years, there is a kind of a trend. Things do move. It's not static, but it is surprisingly stable. Okay, let's look at something else. Let's look at RedMonk. It's a different survey. It's a similar picture. Some of the names are slightly different positions. They use different ranking criteria. But one thing we can observe is that whatever you think, change always comes later than you think it should. Much later. Here, they've got a ranking. They've described this in terms of Stack Overflow, GitHub, and so on. Let's have a look at the top 20 there. Now, for some, they go, oh, okay, JavaScript. Number one, yeah, you kind of expected. It's a little bit odd that JavaScript was outside the top 5 in the previous one. On the other hand, I'm looking at this and I'm going, that's kind of weird. Some of those don't really feel like they want to be in there in that sense. And TypeScript is present, which feels right, but there's a few other things there that don't feel right. In other words, I don't see MATLAB there, which based on my client experience. But then I'm also reminded you're always in a bubble. Whatever you think is normal is not. Then there's this rather vague thing, shell. I am going to presume, because PowerShell is present in this, that they mean bash. So most people, when they say, I do shell, shell is not a language. It's not a thing. It's a thing you put to your ear to hear the C. Shell is a class of language. It's not a language. If you mean bash, say bash. So let's have a look at this. OK, RedMonk seems to give us a little more presence of the 21st century, but actually the top 10, still only 2 that were created this century. And those are the old guys. OK, let's look at this. This is kind of the other side of the story. This is the IEEE Spectrum one. Top programming languages, TypeScript and Rust are amongst the rising stars. So rather than say C is falling, Rust is rising. Ah, OK. So there's kind of a correlation there. If you like types in your language, you might see this as a strong point. In fact, the majority of any of the top 20s are statically typed or have optional typing. Draw your own conclusions. I have not analyzed that. And again, here we see a power law. Okay, Python way ahead by a very long way. And this one, I've corrected shell to bash. This one is actually a little bit more similar to the first one in the sense of there are only 6 there in the top 20 that were created this century, and everything else is older. So one of the things, given that we go to a lot of conferences and there's a lot of people talking about really interesting languages, I'm going to quote from Bjarne. There are only 2 kinds of languages, the ones people complain about and the ones nobody uses. We have to understand that this is mostly social stuff. So I did a thing, is I merged all 3 top 20s, so therefore removing duplicates. I also removed languages that were definitely in no way Turing complete, so HTML and CSS. Okay? We can debate whether or not SQL is or is not Turing complete. It's not relevant. It is, for our intents and purposes, it is sufficiently equivalent until you hit an edge case. But that's true of all languages. So I've ordered them. I have ordered them by when they were introduced. And of course, I've had to use different criteria because criteria change over time. Once upon a time, there was no such thing as open source. You couldn't say this is the first commit of the language. Sometimes languages existed in a designed but unimplemented state. Sometimes they existed in unreleased states nobody had access to, and so on. But on the whole, this comes out fairly reasonably and fairly consistently. So let's do this by decade. A big bump in the 1990s. 1960s, what happened? Flower power. The Beatles. Moon landings. Actually, it turns out the 1960s were hugely important, massively important, but not for the set of languages, but for language features. There is a marked difference between the before 1960s and post-1960s language. Now, I've done this ranking before. A couple of years ago, I had to redo it because I had to update all 3 surveys. RedMonk, TIOBE, and IEEE. And there are other surveys, by the way, if you want to look. If there's quite a good aggregate one. If you go to plrank.com, it shows a whole lot of stuff. It also has criticisms of each one. plrank.com, Connor Hoekstra from NVIDIA puts that one together. It's definitely worth a look. But I decided one day, it was just when I was kind of inspired by the fact that the book that Trisha G and I edited, there's a contribution. So 97 things every Java programmer should know. There's a contribution from Ben Evans, where he talks about Java is a 90s kid. Now, normally, we kind of think of 90s, we often refer to them as millennials. And I thought, what happens if I use social Western generations? That's quite fun. Big millennial bump. Now, I also find this quite interesting because what it actually means is that most people entering the workforce will be using a language that is older than them. That is, the top 5 languages are going to be older than Gen Z. When I started work, the first language, apart from 4GL, which I have certainly outlived, the first language I was properly paid to write was a boomer language. It was Fortran. That was when I was 21. By the time I was 22, I was programming in a language that was younger than me. These days, that's less likely, and will continue to be so. It's not a moving bump. In fact, you can see this in case. Let me just highlight the ones again. These are the ones that appeared in any of the top 10s. What's going to happen is that millennial bump is going to stay there. It's going to nudge into Gen Z gradually, but it's going to start smearing. It's not a kind of beautiful Gaussian curve that moves with time at all. It's going to stay. It's going to be sticky. So let's go to the 1960s. Algol 68. Who has heard of Algol 68? Who has programmed in Algol 68? Okay, great. Yeah. One of the most influential languages that you either never heard of or never used. Let me just pick on something. Let's pick on some words that appeared in Algol 68 for the first time. Yeah, ever wonder where these came from? If you look at everything else, it was always integer. Boolean, yeah, we spell out the whole word, character. Fee, elif, void, struct, union, that's where these things come from. So this report, there was the initial report and then a redraft in the early 70s. Adrian van Wijngaarden was one of the key people responsible. Make a note of that name, we're going to come back to it. What I'm going to do is I'll show you a little example code. What's this? Fibonacci. What do you use Fibonacci for? Story points. No, you use it. No. That's a big no. I know this is not a methodology talk, but no. You use it to convert between miles and kilometers, because this converges on phi, which is within 0.5% of miles and kilometers. Okay, that hack, if in case you ever need it, there it is. 8 kilometers is about 5 miles. 13 miles is about 21 kilometers. Works both ways. It's really nice, yeah? Finally, there is a use for it. Story points was not it. Okay, so if you work in kilometers and you are watching something from the US or the UK, you can now easily switch between that. Okay, that is actually of greater utility. Okay, if you're stuck with the legacy units and you're going to what we call the rest of the world, you're welcome, anytime. So we can summarize this like this. And I can write a piece of code here. Now, what's interesting about the Algol 68 code is this is a procedural language. It is expression-oriented. There are no return statements. This is where phi comes from for those bash people. As a procedural language, it was fully procedural. You could pass unnamed procedures around. Useful feature. We'll see a bit more of that later. Anyway, are you going to this year's Fibonacci conference? It's going to be as big as the last two put together. Yeah, I think that's slightly better than the first one. But I know you're here at GOTO. And there is an issue with GOTO, and I don't mean the semicolon. That has worried me for years. The positioning of that is uncomfortable. I'm going to take you back to 1968. I'm sure everybody's familiar with Edsger Dijkstra's famous rant, A Case Against the GOTO Statement. And you're going like, that's not quite how I remember it. Oh, you mean as it was published? GOTO statement considered harmful. You see, when Dijkstra wrote it, it was a much more modest title. But this is 1960s clickbait. This is from Niklas Wirth. He was the editor at the time. Niklas Wirth at ETH, the late Niklas Wirth, unfortunately, responsible for Pascal, modular Oberon, and a bunch of other stuff. Thing considered harmful, pure 1960s clickbait, and you can now just do anything considered harmful. This was a time when people were really talking about the idea of structure and being rational about structure, structured programming. And in this book, we see Dijkstra, we see Tony Hoare, Ole Johan Dahl, one of the inventors along with Christian Nygaard of Simula 67. Yes, object orientation was originally considered to be part of structured programming because it's structure as opposed to not structure. And there's a whole lot of stuff. We're going to come back to that. So we can see this idea of structure. In fact, one of the ways of thinking about structured programming is just to use the word block structure. This is the abiding idea, the most important idea. This is a notation, a programming language, Plan Calcul, developed by Konrad Zuse in the mid-1940s. Konrad Zuse responsible for effectively the world's first programmable computer, created electromechanical devices from the late 30s onwards. Came up with this very elegant notation. You can immediately see a problem in terms of input, but it is very elegant. But let's just translate. This is a function, Ordnung. It's a sorting algorithm. I worked it out. It's a bubble sort. That's effectively a block. Wiederholung, repetition, a while loop. Then we've got a conditional. They were single guards, because if you wanted to do an else, you just did if not. And then in the middle of all of this, we suddenly have a little piece of French. Fin. Break. Okay? So you can see there are issues with trying to program like this, elegant as it is. And this inspired a number of other languages and ideas for languages. And so Heinz Rüteshauer, who's a Swiss mathematician, also at ETH, in the early 50s came up with this notation, superplan, and had designed this thing. What is the most notable here is, apart from the uncomfortable lack of indentation was not a thing until about 64, and even then it took a while to catch on, is that Heinz Rüteshauer invented the for loop. For loop is not based on English, it's based on German. Then we have other fundamental ideas that came in. This is from a talk by Erika Fischer, which I'm here to talk about what seems like an absurd idea, that if then else had to be invented. Because else, that's not English. I mean, else is an English word, but that's not how we speak. We never say if something else. We say if something or else, or if something otherwise. Grace Hopper in Flowmatic, she used otherwise. John McCarthy, who went on to invent LISP, he originally had a formulation that was based on if and otherwise. But otherwise is quite a long word. And in this preliminary Algol 58 report, so we see Rüteshauer mentioned there. We have Fritz Bauer and Hermann Bertenbruch, who are both in Munich. And we have Klaus Samuelson. That's the person to watch. Klaus was very impressed by John McCarthy's ideas and tried to integrate stuff. We see else as a descriptive notation for a three-way switch, but not yet as a keyword. That had to wait until around 1958. Alan Perlis, who I mentioned before, Klaus Samuelson, and we see or if and if either. That was the Algol 58 proposal. But by the time they got to Algol 60, and there's a bunch of names here, everything I've mentioned before, plus Backus and a few bunch of others, and Van Wijngaarden, they're all there. It's quite a crew. This is where else comes from. We also have other things. Our units of composition above that, we variously give them names, functions, procedures, subroutines. These days we tend to converge on function, which really annoys some of the functional programming people who say, no, that's not what function means. I've got really bad news for you. Yes, it is. Welcome to English. Function does not have a special meaning no side effects. That's called a mathematical function. If you need to say that, you put the word mathematical in front of it. Function on its own typically means a bunch of stuff that you've just done and it could have side effects. Okay? It doesn't have a special meaning. The mathematicians do not get to move in on that territory. Okay? But subroutines was particularly popular in Star Trek. You can tell Star Trek's from the 1960s, because they still talk about subroutines. The only people these days who talk about subroutines are VB programmers. Donald Knuth, Observe, subroutines are special cases of more general program components called coroutines. In contrast to the unsymmetric relationship between a main routine and a subroutine, there is a complete symmetry. He wrote this in the early 60s, and he credited Melvin Conway with creating the coroutine in 1958. Melvin Conway wrote up some of this stuff in the early 60s. And if you're wondering, yes, it is that Melvin Conway. Yeah, Conway's law. Yeah, he's been inventing the future for years. We're only just catching up. And he talks about them. They're at the same level. What I like about this is that for a lot of people, I read a blog post a couple of years back saying this new invention, coroutines. When I was getting into programming, coroutines were just going out because everybody suddenly thought preemptive multi-threading was the answer. We are playing catch-up. We see it in a number of other places. The concept was pervasive. Mid-1970s, 1973, 1974, Barbara Liskov. Yes, that Liskov substitution. She won the Turing Award in 2008. She basically invented, well, yeah, she did invent ADTs. She always got her students involved. Created a language called Clue that was still used at MIT, at least into the 80s, as a teaching language. And they created this idea, a coroutine-like idea that was called iterators. But they said, the use is sufficiently limited that we don't actually need to set up a separate stack. We can use the regular stack. So here's a piece of Clue, our old friend Fibonacci. We're going to avoid recalculation. If you're interested, historically, that's a for each loop, 1970s. And here we see the structure of this. Optional semicolons, 1970s. In case you were under the mistaken belief that that's a new idea. Multiple assignment, A comma B equals B comma A. Not 1970s, but 1963. Okay? Some people are just getting excited about having it in their languages now. Folks in Python, tuple-style assignment, and so on in C#. They've all got the same yield structure, 1970s. So Bjarne, in Designing Evolution of C++, he makes an observation. Before C++ was called C++, it was called C with classes. First real code to be written in C with classes was the task library, which provides Simula-like concurrency for simulation. One of the most important things about Simula 67 is that it supported coroutines. Because it's a simulation language, you need to have some kind of concurrent expression of the real world. Unfortunately, the way that C++ does it, or did it, and now C++ has got coroutines in the library, is a little bit like this. Some assembly required. But before 67, there was Simula 1, which didn't have objects, but it did have coroutines. They had an operating rule. You could suspend something, and that was vital. So let's go back to structured programming and talk about one of the most important ideas, which is the block structure. The idea that you can have a block that contains procedural code, data, and so on. Hopefully you've had breakfast and this doesn't trigger you. Here's a stack of pancakes, so let's talk about stacks. So this is an extended Algol 60. We've got begin, end. I've got an array of pancakes that's referenced to pancakes, and I've got a count of the things that I've got. Then I've got a bunch of procedures for operations, push and pop and stuff like that. And then I can put some other executable code here. Now all I'm going to do is I'm just going to assign it to 0, which doesn't seem very useful, except what happens next. A procedure which is capable of giving rise to block instances which survive its call will be known as a class, and the instances will be known as objects of this class. In other words, a block contains executable code and data. And then when you leave it, normally it goes. The idea is, well, let's keep it around, give it a name. Bingo, a whole paradigm. Interestingly, though, the data was not private. That we really got from two other sources. Barbara Liskov, ADTs. Abstract data type defines a class of abstract objects. There was no private keyword in Simula 67. It only privacy, or the word hidden, was only added formally in 1986. Completely characterized by the operations available on those objects. A program is concerned only with the behavior that object exhibits, but not with any details of how that behavior is achieved by means of an implementation. Sound familiar? Take it together with Parnas's, before that, You know the way that people keep using stack examples for abstract data types and for test-driven development examples and stuff like that? This is the first one. This was Barbara Liskov, 50 years ago this year. Happy birthday, stack. It's not that stacks have been around for ages, but as an abstract data type, this is the first one. And notice it's called top, not peak. Naming is hard, but when somebody's already given you the good name, don't go back on it. Use the original source. It was right. Parnas's work, he talked about privacy. A data structure, its internal linkings, accessing procedures and modifying procedures are part of a single module, 1972. But there was another idea in the 70s, CSP, another way of keeping your data private. You held it within a process, not necessarily an operating system process, but something that had protected state. The way you communicated was by using channels. This is Tony Hoare's approach. Based on this, in 1983, a language called Occam was created. Occam was very closely based on ideas from Algol 68, CSP, and BCPL, which derived from CPL, which is where the multiple assignment came from. BCPL ultimately gave rise to C, in case you're interested. Occam is the most strict language I have ever used. It makes Rust look like JavaScript. Its compiler is brutal. If you get something wrong, you will not get a cascade of errors. You will only get one error. It stops. I'm done. First error, that's it. You fix it. I'm not coming back. I'm not going to look at the rest of the file or any of your other files. People talk about opinionated languages. They have no idea what that actually means. This is opinionated. It is one of the most procedural languages. It is the most perfect block-structured and procedural language I've ever used. But it has such a strict idea of immutability, it makes Haskell look like C. This is a fascinating language. This is where I learned about channels. It's where I really appreciated orthogonal design and consistency. These days we kind of had to put up with Go, which is not a bad effort, but, that's what most people think of as channels. Sophie Wilson said yesterday, we still need a revolution in software. Well, we are so far behind. We're doing very, very slow evolution. Very slow. So let's go back to John Backus. Conventional programming languages are basically high-level, complex versions of the von Neumann computer. Okay. Von Neumann programming languages use variables to imitate the computer's storage cells. He's concerned about the von Neumann bottleneck, which is the fact that it's very much this whole issue of how do we increase the parallelism when our fundamental models are actually sequentialized in many ways. Control statements elaborate its jump and test instructions, and assignment statements imitate its fetching, storing, and arithmetic. So let's go back to that aggregated list. This is 29 languages. It's all the Turing-complete languages from all the 3 top 20s that I look at. And let us look at this set of 29 languages that are popular, and let's highlight all the ones that are functional programming languages. There is not a single FP language in there. Oh, if we ask a different question, languages where people have borrowed things in, or where there are articles encouraging a functional style, but yes, it's a functional style. It's like a light sprinkling. It's like when somebody who is an omnivore says, I'm just going to have vegetables for lunch. I'm a vegetarian. No, you're not. You're just having vegetables. These languages are not functional. They are multi-paradigm, hybrid at best, but multi-paradigm. I'm not going to criticize that, but I'm just going to say we're already getting an answer to John Backus's question. The funny one that people normally leave out of this one is the one language in the top 20s that is actually declarative. SQL. Now, of course, extended versions add proceduralism, but its heart is it grew from a declarative center. Some people confuse declarative and functional. A lot of the time when people say, I'm using a functional style, you look at it and you go, you're not. This is good stuff, but it's declarative. Declarative is the larger set, the broader paradigm. Yeah, just as imperative is the broad paradigm, and then we have within that various factions. So we see this, if we look at we try and filter out some even numbers, this formulation is logic programming. It's not functional programming, but we find it in many places, and a lot of FP people claim it as their own. Notice how one domain, this is always true, claims something as their own. They normally steal it from somewhere else. I'm British, I know this. This is what it looks like in Python. It's comprehension. I do this in Haskell. And the Haskell form is actually the closest to the original set builder notation that we find in set theory and first-order predicate logic. This also inspires things like link in C#. Structurally, that's the same. That actually compiles down to this. If you're looking at this in Java, just add a little extra. The point is here, we've shifted over to pipelines. Now, we often think about pipelines as being a functional idea. They're not. They're originally treated very, very differently. They were originally a data flow architecture, was treated separately from the concept of FP. FP's boundaries have grown. But pipeline-style stuff or concatenative programming, there's a lot of different variations of this. But I find it interesting that this was also accidentally reinvented by Doug McElroy back in 1964, which is 60 years ago. This is Brian Kernighan's copy of this memo, which foreshadows a feature in Unix that we know as the pipe. We should have some way of coupling programs like garden hoses, screw in another segment when it becomes necessary to massage data in another way. This is the way of I/O also. This has given rise to direct data flow concepts as well as collection pipeline styles. But when it comes to data flow, perhaps the king of them all is Excel. Did you notice Excel was not in any of the top 20s? Because people don't regard it as a real programming environment. But actually, that's where most of the world's code is. Simon Peyton-Jones, known for his work on Haskell, makes this claim. Excel is the world's most popular functional language. This pisses a lot of developers off, because it turns out the people in the accounts department have been doing FP for longer than they have. Now, just before the pandemic, when I say just before the pandemic, I literally mean March 2020. I was over the bridge in Malmo, giving a talk at Beauty and Code on Lambdas. And I made this throwaway remark about Excel. Don't put Lambdas in there, it's not going to help. Please don't put Lambdas in there. Anyway, the pandemic does strange things to people. Later that year, they put Lambdas in, because they were bored. It's just like, yeah, let's put lambda calculus in Excel, because that's not going to cause any problems at all, because everybody's spreadsheets are already working. Instead of fixing Excel's deep fundamental flaws, the type system, oh no, we'll add something that nobody in that space is going to use. They were better off when they added Python. That was a smarter move. Lambda calculus, where does that come from? Well, that's Alonzo Church. This is the paper often people credit with this, 1936. An unsolvable problem of elementary number theory. This actually was done at the same time that Alan Turing was doing his work. Alan Turing used a simple automata to capture what is computable and what is not computable. Alonzo Church took a different route. So we sometimes call it the Church-Turing thesis as a result. Independent, but actually convergent. But actually, this wasn't the first time it was used. Church actually created lambda calculus in 1932. And this paper, unfortunately, was shown to have inconsistencies, but he was able to repurpose the notation, the calculus he'd created. There's a wonderful observation from 2009, the late Will Cook, on understanding data abstraction revisited. Lambda calculus was the first object-oriented language because it captures closure. It allows data abstraction. It allows polymorphism. It's a really interesting look. And again, it's quite interesting because, remember I said that Algol, a perfectly procedural language, allows you to pass around anonymous pieces of code. A lot of people in the FP space say, Lambdas, that's ours. No, it isn't. It's everyone's. It turns out every paradigm has got it at its heart. It just happens to have a very particular and special place in FP. So, has anybody seen this Randall Munroe XKCD before? If you've not, hey, well done. It's an awesome one, particularly if you're a mathematician or a physicist. All the others don't get such a good look in. Sociology is just applied psychology. Psychology is just applied biology. Biology is just applied chemistry, which is applied physics. It's nice to be on top. Anybody here with a physics degree? Yeah, you must have walked around like this. I certainly did. Yeah, and then you got the mathematicians. Oh, hey, I didn't see you guys all over there. Yeah. But the thing about maths is it's not real. Yeah? Sometimes, people say, oh, it's fundamental. No, it isn't. It's useful. It's not fundamental, but you can describe everything. Guess what? I can do that in English as well. That doesn't make it fundamental, okay? It's just useful. Physics is real. Yeah? Okay? Team physics? Good. Right. Anyway, the reason I'm doing this is not just because I'm seeing Randall Munro next month live in London. I've seen him before. He's absolutely brilliant. If he comes your way, make time. I thought, oh, languages arranged by when they included lambdas. Java, the language of the internet, fast-moving, fast-paced, 2014. Wow. After C++ got lambdas. Yeah, Java's so fast-paced. C#, sitting there. JavaScript, small talk, nice to be on top. Lisp, hey, didn't see you guys all the way over there. First implementation of Lisp was 1960. John McCarthy. Some really nice ideas in there. Very, very influential language as well. I actually looked at the language rankings. Lisp is actually higher than Clojure. So, yeah, you Clojure guys, bye. It's been good. Lisp is just constantly there in the top 30. Sometimes it nudges into the top 20, but I think everybody should have an obsession with a Lisp-like language at least once in their life. It's really healthy for you. And there's some really interesting ideas. What is interesting is that in Lisp, McCarthy actually ended up using this notation, which doesn't look like his original notation for the if and otherwise. It has a lot of other similarities, but a multi-way conditional, and they're just using true as the else case. Later Lisps then actually acknowledged that if was a far better word than conned. Nobody likes being conned. It's not a good feeling. You've been had. It's much more direct. But conned is always there. Now, the thing we have to remember is that Lisp was originally introduced for machine learning. This kind of brings us to an interesting place. Machine learning algorithm walks into a bar. Yeah. Bartender asks, what do you have? Algorithm says, what's everyone else having? I told you they'd get better. But here's the truth. The truth is that that is how this works. That is how LLMs work. That is how any form of neural network system works. It is based on what we have seen before. It is based on statistical relevance, which is interesting because what that tells us about the future of programming languages is not that it's dead, but somebody's going to it's been moving slowly for a very long time. It's never moved as fast as you think it would. It is one of the slower elements of our ecosystems. We often think of technology as fast-paced, but actually, programming languages are not that. Now, individually, the languages do evolve. But what I'm interested in here is to make a separation. There's the set of languages, which is surprisingly stable, and then there's their features. Each new version brings something new, but normally it's from somewhere else. It turns out that programming language evolution and experimentation, people are doing plenty of experimentation. Please don't get me wrong. It's not like there's an absence of ideas out there, although actually there is. But many of the ideas that people are coming up with are either never going to see the light of day in the top 20, anybody's top 20, or it's going to take a very long time to get there. Session types, dependent types, these things have been around for a while. I don't see any major moves in the major languages for these things. There's a lot of stuff in the long tail, but in the dominant few, and even those just outside it, there's relatively little. It's mostly matters of taste and syntax. And why have I raised this at this point? Well, first of all, obviously, I had to say something about machine learning, because are you even giving a keynote if you're not talking about machine learning? Yeah? I can just imagine the reviews. Did not talk about machine learning. Not relevant. No, it is hugely relevant, because what you realize is the reason Most of the debates about programming languages, I love programming languages. I think they're great. I have favorites and favorite features and all the rest of it. But at the same time, I also recognize some of them are personal preferences, but all of it is social. If you try and look at it from a purely technical point of view, you will not understand programming languages. You will always be mystified as to why the way the world is why it is that way. So the point here is you need to understand it as how people work. And now you need to understand it as how AI works, because it means that all of the data that is out there, it has a decelerating force, because most of the advice, so here's an amplification. If these languages are in anybody's top 10, they will remain there for quite a long time, because that's where all the help is. That's where all the suggestions is. That's where all the good stuff is. If you try getting suggestions for languages that are less well known, they are more likely to be wrong. You are less likely to be supported. If you are asking for things to be generated, you will end up with language, not just languages that are already incumbent, but typically older versions of those. Because that's where the bulk of the past is. The past is huge. There is a lot more past than there is present. And that weights the data. So I'm not saying, if anybody walks away and says, oh, Kevlin says the programming language evolution is dead, I will find you and correct you. Yeah. But I am saying that the effect that LLMs are going to have on software development evolution, and from the programming language perspective, the brakes are on hard. It's going to slow down. It was already slow. It's just going to slow down some more. There's still going to be innovation. People are always going to create new languages because, a lot of people create new languages because it's fun. They're not after dominance. They're after personal enjoyment and success. That's fine, but we just need to understand that from a different point of view when we start looking at the code bases in the world. So let's go back to this. The observation made in 77. Each successive language incorporates, with a little cleaning up, all the features of its predecessors plus a few more. It doesn't make a clean break from the past. Those languages that now have functional style features, they have not made a clean break with the past. What they've just done is added stuff. One of the things I find interesting is Algol 68 was criticized for being too large. If you look at the definition manual, it's quite small by modern language standards. The language CPL that I mentioned before, Combined Programming Language, 1963, was a joint project between the University of London and the University of Cambridge. It was considered to be too big, which is why BCPL, Basic CPL, was created as a systems language. In other words, it was a subset from which we get C. I even saw something, in fact, it's in the TIOBE thing, and I still see it elsewhere, where people say, oh, C is a small language. Who are you kidding? I've worked on the C standard and the C++ standard, and I can tell you, C++ standard has its own gravitational field, it's so large. But I can also tell you that the C standard is no small asteroid either. It's enormous. It's huge. It is larger than the Algol 68 definition. Our idea of what is large has changed. That's the nature of legacy. The point here is that one of the things Backus didn't anticipate, because it was programming languages had only been a thing for a couple of decades, is this variation. Each successive version, he did not really anticipate the way that we would version things, that languages would live on and on through multiple versions, that you could start in the 1970s at the top of the file and end up in the 2020s by the time you reach the end of the source file, going through half a dozen different styles in between. Each successive version incorporates, with a little cleaning up, all the features of its peers, plus a few more. What you find is that most of the additions to most of the languages in the top 10 are convergent. Sure, there's clear differences in tribalism, there's clear differences in syntax, but they are all borrowing from the same pool. So last night's discussion, I had to go to it because it was about stuff that was going to be related to this talk. And I was getting all the way through. I thought, there's no good quotes to take from this. And then Daniel came out with this. Java as a language is interesting. Fuck no. No, it's not. It really isn't. And I mentioned this afterwards, and Martin said, that's the point. Java is not an interesting language. It has not been an interesting language since 1995. Its first major release was 96, just in case you're wondering. But that also tells us something else about this. There is a question in the title, and this is interesting because I hadn't set out when I originally put this talk together. It was only this week that I kind of realized. There's a thing called Betterigde's law of headlines. The maxim that any headline that ends in a question mark can be answered no. And we can now say in 2024, the answer to that question in 1977 is no. It's a resounding no. We are about 40 years on, and it's not even that we're not close to what John Backus was hoping would happen, is we are as far away as we've ever been. And the reasons for that are not technical. The past is never dead. It's not even past. Thank you.